These are your instructions. In general, you just need to follow the PowerPoint. Please make sure that the sound is turned up on your device so you can hear the narration. On each slide, there is a yellow box with some instructions in it for you. If a slide asks for homework, don't forget to send it in via Show My Homework. And if a slide asks for Educate to be completed, don't forget to do it by the date shown on the slide. This is lesson 2 on forces and elasticity. And our objectives are to recall the key equations that we should know by now from the section on forces. We're going to try and carry out some two-step calculations, and then we're going to do some practice questions. This is our starter activity. By this point in your work on forces, you should be familiar with some key equations. See if you can answer these questions. Number 1, which equation links mass and weight? Number 2, which equation links work done and force? Number 3, which equation links force and extension? And number 4, which equation links elastic potential energy and extension? Pause the video here while you try and do the activity. Be honest with yourself. How do you think you did? Did you manage to get all of them? You need to be familiar with these equations so that when you're facing an exam question, you know which equation you're going to use. Some questions will involve you using more than one equation, so you need to know all of the terms and all of the units for all of the equations. Let's go through them as a revision activity. Number 1, which equation links mass and weight? W equals mg. Weight equals mass times gravity. Weight is a force measured in newtons, mass is measured in kilograms, and gravity is measured in newtons per kilogram. Number 2, which equation links work done and force? Work equals force times distance. Work is measured in joules, force is measured in newtons, and distance is measured in meters. Number 3, which equation links force and extension? F equals Ke. Force equals spring constant times extension. Force is measured in newtons, the spring constant is measured in newtons per meter, and extension is measured in meters. Number 4, which equation links elastic potential energy and extension? EE equals a half Ke squared. Elastic potential energy equals a half times K times the extension squared. Elastic potential energy is measured in joules. The spring constant is measured in newtons per meter. Be very careful. That squared term at the end refers only to the extension. Don't make the mistake of squaring the whole of the equation. It is only the extension that you need to square. We're going to use these equations to do some two-step calculations. These are higher level calculations where you sometimes have to use two equations. The first equation is used to calculate a quantity that you then substitute into the second equation to get your answer. Let's have a look at a worked example. A spring extends by 0.15 meters when a force of 50 newtons is added. How much energy is stored in the spring? Well, the first thing to note is that our units for the extension are already correct. Here it is in meters, not centimeters, and the force here is in newtons. So eventually we're going to work out how much elastic potential energy is stored in the spring, but first of all, using this and this, we can work out K, the spring constant for the spring. So let's write down our equation, F equals Ke. This time we want to find out K, the spring constant. So rearrange the equation, gives you K equals F divided by E. You know both of those things. Substitute the figures in, gives you an answer for the spring constant of 333.3 newtons per meter. Now you know that, you can do what the question is actually asking for. You want to work out the elastic potential energy stored in the spring. Now you know the spring constant and the extension, so put your formula down. Elastic potential energy equals a half Ke squared. Substitute in all of the figures. gives you an answer of 3.75 joules. Let's have a look at another slightly more complicated example. A student hangs a weight on a Newton meter. The energy stored in the spring is 0.045 joules. The student adds 2 newtons to the Newton meter. Find the total extension of the spring, and the spring constant is given as 400 newtons per meter. Okay, to start with, we can use this piece of information here, which is the elastic potential energy stored in the spring, and the spring constant to work out the extension. And you do that by this. First of all, write down your equation. The elastic potential energy equals a half ke squared. If you rearrange that formula, it gives you the extension squared is equal to the elastic potential energy divided by 0.5 times k, the spring constant. So a little bit of algebra required there. If you are having difficulty doing the algebra, remember you can always put this into a formula triangle and then do what we've done in class and just cover up what you need to find out, and the triangle will rearrange it for you. So from that, if you substitute in your figures, you get that the extension squared is equal to E divided by 0.5k, put in your figures, and gives you E is the square root of 0.045 divided by 0.5 times 400. And that gives you an answer of 0.015 meters. So what you've worked out there is the extension. Okay. Now, it says the student adds an extra 2 newtons, and you want to work out the extension. You use, now that you know K, and you know the force that's been added, 2 newtons, you can work out that E equals the force divided by K. Substitute in your figures, gives you an extension of 0.05 meters. And then the final part of the question is to add the two together to give you the total extension, 0.2 meters. So that is quite a complicated example. You might have to work your way through it more than once till you get the hang of it. And as I said, at this point here, if you're having trouble rearranging this formula, then put that into a formula triangle like we did in class. Now it's time for you to get some practice using the formula for elastic potential energy. I don't think there's any need for you to do all of them. Do the first 5, check them using the answers on the next slide, and if you're okay, then you can move on to the next slide. If you have a problem or you need more practice, then please feel free to do all of them. And here you can have some more practice. Again, just do the first 5. The only difference here is that you might need to convert the units that the extension is measured in. Do the first 5, and if you're happy with those, green pen them, and if you've got them right, then feel free to move on. If you're having trouble, do some more. And the final activity of this lesson is to complete this sheet, fill in the empty gaps, and do the table at the bottom. Record it all in your book. Thank you.